Alright, so now I'm going to do example 8 in the note. This is a special example, a different one than what we have doing so far. So I have written the matrix form and I have initially started the process to find the eigenvalues. Okay, so here I will not find the determinant in this video, but I will rather give it to you. So pause it and try to do it and convince yourself. Okay, so the determinant is lambda minus 2 cubed is equal to 0. So actually the eigenvalue is 2, but it's repeated 3 times. Okay, so that's the difference. Now how do we do this? Let's see. Okay, all right, so let's take eigenvalue 2 and find the eigenvector. So we want to solve the equation a minus 2i times capital K is equal to 0, capital K1. Okay, so let's see, you subtract 2 from the diagonal to get a minus 2i matrix. So we get 0 1 6 0 0 5 0 0 0. So this is much good matrix. Right now you want to solve this for K1, K2 and K3. Now as you can see, do we need Gaussian elimination here? Well, the problem is simple enough that we don't need Gaussian elimination. Anyway, the pivot positions are 0, so there's no way to make those pivot positions non-zero. And on the other hand, these numbers below the pivot positions are 0, the entries are 0, so we don't need Gaussian elimination because we get simple 2 equations from here. See, K2 plus 6K3 is 0 and then 5K3 is 0. So what do you get? K3 is 0, right? So K3 is 0. K3 is 0 means K2 is also 0, right, from this equation. Now we don't know K1 because we don't have K1 in the equation, so we can choose K1. Let's choose 1 to be K1 so that it makes simple. So this is the only eigenvector we can find. Okay, so we have 2 more generalized eigenvectors, right? Because this is repeated 3 times. Now let's find the second generalized eigenvector. By using the equation a minus 2i, we want K2 now, but I use capital K1. So a minus 2i matrix is still 0 1 6 0 0 5 0 0 0. K2 is what we want to find and K3 is 1 0 0. Okay, so now if we write the equations from here, K2 plus 6K3 is 1, 5K3 is equal to 0. So again you can see K3 is 0, right? And since K3 is 0, K2 will be now not 0. If you substitute 0 here, K2 will be 1. Now what can we choose for K1 here? So here K1 is free. So we still don't know what is K1. So let's choose K1 to be, how about 1? Or how about 0? Okay, let's choose K1 to be 0. So that is K1. So this means capital K2 is this eigenvector. So this is a generalized eigenvector now. Now we want to find the third generalized eigenvector. So we use the equation a minus 2i. Now we want to find capital K3. But now we use capital K2, the previous eigenvector you found. Okay. Alright. So that's the only difference. So a minus 2i matrix is again 0 1 6 0 0 5 0 0 0. Here little K1, little K2, little K3. The only difference is the way we write the solution. Okay, so be with me. So 0 1 0 is K2. Now here again no need of Gaussian elimination. 2 equations will be K2 plus 6K3 is equal to 0. 5K2 K3 my bad is 1. So now you can see K3 is 1 over 5 right from here. So K3 is 1 over 5. So that means K2 is K2 plus 6 over 5 because K3 is 1 over 5. So K2 is negative 6 over 5. So negative 6 over 5. Now we can choose our K1. Why don't we choose our K1 to be 0? Okay, little K1. Alright, so now this is capital K3. Now to make capital K3 simple, what we can do is multiply capital K3 by 5 so that we can get rid of fractions. So 0, negative 6 and here this will be 1. So this is capital K3. So let's write down the summary. So what are the eigenvectors, eigenvalues we had? So the eigenvalue is, I think, I forgot the eigenvalue. Eigenvalue is 2 repeated 3 times. Capital K1 is 1 0 0. Capital K2 is 0, 1, 0. Capital K3 is 0, negative 6, 1. Okay, so now let's write down the general solution. Okay, so let's write down the fundamental set of solution. X1 is K1 1, 0, 0 e to the 2t. X2 is K2 0, 1, 0 e to the 2t plus t times K1 1, 0, 0 e to the 2t. Now X3 is the difference. X3 K3 0, negative 6, 1 e to the 2t plus K2 t times, okay, so t times K2 0, 1, 0 e to the 2t plus t square over 2 K1 1, 0, 0 e to the 2t. Okay, so this is the third solution. Okay, so now our final solution is just the linear combination of these three. So C1 arbitrary constant 1, 0, 0 e to the 2t plus C2 this whole thing. Okay, so let's write it down for the ones in the lifetime, e to the 2t plus t 1, 0, 0 e to the 2t plus C3 the whole thing here, 0, negative 6, 1 e to the 2t plus t 0, 1, 0 e to the 2t plus t square over 2 1, 0, 0 e to the 2t. So this is the general solution, bit a longer one for our system of differential equations. Okay, all right, thank you.